Hello everyone, my name is Wei-Hao. I am a fourth-year PhD student in the Department of Computer Science at Purdue University. Today, I am going to talk about our paper, Dango, a mixed-initiative data wrangling system using large language model. This work is done by a team of amazing people from Purdue, Wrangling University of Science and Technology, and the University of Iowa. Okay, let's get started. So, what is data wrangling? Well, data wrangling is a very important and very first stage in the data science pipeline. It transforms the raw data into a more suitable format for later data analysis. For example, if you have such a table with ID and full names columns, you might want to split the full name into first name and last name columns. However, in practice, data is usually dirty. A recent study shows that it could take up to 80% of the time to clean the data in data work, especially for non-experts. They need to deal with many data issues such as missing values, duplicates, and inconsistent formats. So programming by demonstration, or PBD, becomes a promising solution to these challenges. In PBDs, users simply provide a demonstration, and a program synthesizer will generate scripts based on the user demonstration. However, current PBD systems still have several limitations. For example, existing PBD systems only support single table operations. Also, it's difficult to correct errors. In addition, it's hard to demonstrate more complex operations. For LLM-based systems, users can simply prompt the LLMs to clean their data. However, these LLM-based systems also have some limitations. First, LLM can easily misinterpret user intent and generate incorrect operations. Second, LLMs are prone to hallucination. Third, non-experts usually struggle to effectively communicate with LLMs. To summarize, the main HCI challenges in existing data wrangling systems are user intents, a lack of multi-table supports, validation, and control. To address these challenges, we proposed Dango. Let me show you how Dango works. Suppose we have two tables, and we want to perform a statistical test on the values of the years of experience column in one table with the age column in the other table. If the result is statistically significant, we remove one of the columns while keeping only the other one. This example is inspired by the machine learning tasks where we sometimes want to delete redundant features. So this is the interface of Dango. As you can see, there are two tables uploaded. In this task, we choose to directly prompt in the chat box because it is difficult to demonstrate the conditional operations. The first prompt is to ask Dango to perform a statistical test. Dango then generated a clarification question about what types of statistical analysis I wanted to perform and also provided me with some options. Here, I chose the Pearson correlation test. Then Dango generated the natural language program in the bottom right corner. However, this is not yet finished. I prompt Dango again to delete one column if the test result is significant. This time Dango asked me which column to delete, and I chose years of experience. Dango then generated the final program. Once I checked that the program was correct, I ran the script and got the results. Dango also supports a data provenance view in the top right corner. Users can directly click on different versions of table nodes, and the corresponding table content will appear in the top left corner. So, you may wonder about the underlying design of Dango. We designed Dango as a multi-agent framework, which includes three agents: the intent analysis agent, the synthesis agent, and the explanation agent. Dango uses the analysis agent to understand users' intent and ask clarification questions if users' inputs are ambiguous. Once user answers the clarification questions, and there is no ambiguity remains, Dango then outputs a sentence to summarize user's intent. Once the user's intent is clear, the next step is to generate a data wrangling script. Dango extended the DSL definition defined by previous work to support multi-table operations and also supported more advanced operations such as statistical tests. To generate the script, we adopted a self-planning strategy to first generate a step-by-step plan and then generate a DSL program based on the plan. To help user read and understand the program behavior, we used predefined grammar rules to translate each DSL statement into a natural language explanation. To help users fix errors, Dango allows users to edit the NL explanation. Dango also supports a data provenance view to help users track table versions and dependencies. To evaluate Dango, we did a user study with 38 students with diverse backgrounds at Purdue University. We found that Dango helped users complete the tasks using less time with less hallucination compared to 2 other conditions. We also evaluated the impact of programming expertise. We categorized the users into novice, intermediate programmers, and experts. We found there is no significant difference in completion time and number of attempts between these groups. We also found users felt more confident about the synthesized scripts when using Dango. We analyzed the utility rates from our logged events and found that participants had fewer hallucinations and used fewer user-initiated features, such as demonstrations. This indicates that participants in Condition C did not need to spend time on reprompting and demonstrations. Instead, they engaged more with multiple-choice clarification questions, which helped them effectively clarify their intent. To further understand the generalizability of Dango, we conducted a quantitative case study. We chose 24 data wrangling tasks from previous work. Our results showed that Dango can solve all of these tasks. We also analyzed the DSL statement distributions and found that drop and merge are the most frequently used DSL statements. Thanks for your listening. That's all I have today. Please read our paper and feel free to scan this QR code to find out more details.